for this Math Leadership Roundtable with this, I'm gonna say it again, this amazing panel, these three very dedicated educators who have so graciously volunteered their time tonight to share their expertise, to share their passion. We are just we feel really fortunate to have them with us here tonight. So before we get to the good stuff, I'll just go to the quick agenda. So we're going to start out tonight. We're going to get a chance to meet the panelists. Then we'll have our discussion. We will look at some of the questions that that were sent in. We'll try to intertwine those with the conversation. So if you sent in a question, thank you. We received over 100 questions. I was quite surprised, but very pleased. And then Dr. Emily Bauk will share her research on virtual manipulatives. And then hopefully, time permitting, if there's any questions that showed up in the chat or some other questions that were sent in, that we'll try to get to at the end. So I think we're about ready to go. So I am going to let the panelists introduce themselves.
Okay. Hi, everyone. I'm so glad to be here. I'm Nikki Green. I've been teaching for about 27 years. I was a classroom teacher. I taught special ed, and I was a classroom teacher and now a math interventionist, a national awardee for the Presidential Award for Excellence in Math Teaching. I was Teacher of the Year back in 2015. I am currently the president of the Rhode Island Math Teachers Association. And feel free to follow me on Twitter. My handle's right there. And really looking forward to a good chat tonight.
Thank you, Nikki. I was going to ask what you do with your spare time, but it doesn't sound like you have much. All right, Miriam.
Hi, everyone. It's so great to meet you from the great state of Texas. I am a third grade teacher. I have been teaching for 17 years in the classroom. I teach math and science with technology integration. I am part of the Klein ISD district, and please feel free to follow me on my Twitter. It's on the bottom. I always try to tweet out whatever I use with Brainingcamp or anything in the classroom to give ideas to help other teachers, because my passion is to help teachers just as other teachers have helped me.
Thank you. And I can tell. So one of the things I always say about Annalise is I admire her passion. And I can see that, Miriam, that you now are channeling your own inner Annalise. So thank you.
Thank you.
Hello, I'm Emily Bauk. I'm a faculty member in the College of Education, specifically in the special education program at Michigan State University. My research primarily looks at mathematics intervention and education for students with disabilities or those at risk or served within an RTI Tier 2, Tier 3 system. And I particularly spend a lot of my time looking at virtual manipulatives and have done so since about 2013. So I'm a big fan of Brainingcamp. So I'm a huge user of Brainingcamp and looking at how they are effective for students with disabilities and those at risk. And so I'm excited to be able to share and engage with the panelists and everyone here today. And my email is up there as well as my Twitter handle. So I look forward to connecting with anybody.
Awesome. Thank you. And I'm looking forward to what the research tells us. All right. So I am going to stop sharing. And I know one of the things that we wanted with that as we're all fans of manipulatives and hands-on learning. So I wanted to ask each of you just to share what your favorite manipulative is and why. So I don't know who wants to go first. I'm going to go. Emily, do you want to go first? Because you're on my screen. If I go left to right, that would be you.
Sure. I find it very hard to pick just one, so I'm going to mention two very briefly. So first of all, I love the algebra tiles. So I was not exposed to algebra tiles, concrete manipulatives when I was in school and learning pre-algebra and algebra. And actually I first understood how to use them by using Brainingcamp's virtual algebra tiles, and they clicked and made sense. And so to me, I go around telling teachers, I don't know why everyone's not using virtual algebra tiles to help kids understand algebraic ideas. And my next one is your fraction tiles. I love fractions. I go and talk about the highlights of fractions and the importance of fractions in math in general. And I think the Brainingcamp fraction app, it just helps make that so visual to students. And so I'm sorry I took two, but those two are by far some of my favorite Brainingcamp apps.
Awesome. All right, Nikki.
I too have two. I loved the 10 frames for the longest time, just because the ease of using them. But I will say, Annalise changed my mind with the Cuisinart rods, and in her words, the most underused manipulative ever. And I will say that because now I'm hooked on them. They are so versatile, from first and second graders learning how to use them for addition and subtraction, to the older kids using them to help them understand fractions. The possibilities are endless. And so she really has opened my eyes to them. And I love using them with your tasks, within a live session. So I definitely feel that, teachers are scared to use them. And so I encourage them to watch your videos. You've got a few webinars that really do a nice job of breaking it down and just taking that leap of faith and experimenting, because they really are underutilized. So that one is probably my all-time favorite.
Great.
Okay,
All right,
so
Miriam.
I was excited when she said Cuisinart rods, because I do agree it has been one of those, like, how do I even use those, And then as time went by, I started realizing how amazing they are. I use them for fractions. I've used them, the hands-on ones for fraction, and then of course the ones on Brainingcamp. And I found them to be very helpful with word problems, those strip diagrams, and the kids are able to just connect and understand how word problems form with the Cuisinart rods as strip diagrams. And later I can probably show you how I use it for strip diagrams for word problem solving. And I do have to say fractions too. Yeah.
All right. Yeah. I'm sure folks would love to see how you're using the Cuisinart rods as a strip diagram. I'm going to answer the question as well as a former middle school math teacher. I'm going to say algebra tiles, because I love the connection of the geometry with the tiles, right? I mean, just being able to show students how many, if you've ever taught algebra 1 or even algebra, 2x and x squared are this, they think, they get the thinking that these are like terms, right? So algebra tiles is just, for me, it was just that model that I could just really concretely show, hey, look, x squared and 2x are not the same thing, because it's based on that, the area, which they're already familiar with at that time. So I would have to say, for me, algebra tiles probably are my favorite. And I think, and Dr. Bauck, I think you said this as well, I'm not sure if folks really are exposed to them enough, or, well, Cuisinart rods too, right? To feel comfortable with them or understand how flexible they can be. All right. Well, thank you. All right. So one of the things that we, as a product developer, which I've been doing since I left the classroom in 2000, one of the things I like to think of is like, how has Brainingcamp or virtual manipulatives, how did it meet any challenges that you were having, or any problems that you were having? How did it help solve those, or what led you to investigating virtual manipulatives? Miriam?
I will come in. Yes. Okay. So the first time I found out about Brainingcamp is during 2020, COVID year. Okay. And our district, we had actually done hybrid teaching. So I had Zoomies, so my Zoomie people, and Roomies. And I remember really struggling, like, how am I going to reach my online kids? I was really concerned because I need those manipulatives, you know? And so our FAB coordinator, our elementary education math program coordinator, shout out to her, Kim O'Neill. She knew we needed something to be able to reach our kids. So she brought it into our district, Brainingcamp. And it was life-changing for when I was going through that hybrid teaching, because they were able to have the access at home and they could share the code with me and I was able to see it. And especially when it came to that regrouping, because that's something that in order to teach regrouping, you have to have the manipulatives. So I was really concerned, how do I know if they know how to subtract at home? Well, when I saw Brainingcamp, it really helped. I got to model it on, my Zoom screen and show them this is how we do it. And then they would practice with me and then they would share back with me and I could see where their mistakes were. So it was the most helpful when it came to hybrid teaching when I had my online kids. And it continues to be my help because I still do it on my interactive board. My lessons, I can show them and it's so visual versus having the set underneath the document camera. It's so helpful to have it on the board and to have the kids do it interactively with me too.
I love the roomies and zoomies.
Yeah. I survived. I'm being honest. I survived that year because of being able to use Brainingcamp, because that's how I did the fractions. That's how I did everything. If it wasn't for that, I don't know how they would have gotten it. And I was impressed because our state exam, we did have to take it. And I was like, okay, how's this going to work? They actually performed surprisingly well. And I was like, that's awesome. And I know it's because they were able to have access to the manipulatives online, and it really helped. So I was excited.
Awesome. Nikki, I saw you raise your hand as well.
If it was one word, it would be game changer. It absolutely, Brainingcamp came through in a clinch for my district at that time, because we were completely remote and ended school on March 13th, and that was it for the year, and we were completely remote. So to have access, and at that point, the company was offering free trials, and it literally did wonders. So I was always forever grateful, and it literally was a game changer. And at that time, when we did come back, I didn't have the technology I have. I have a Promethean board, but I remember somebody wrote in and asked, how do you use it if you don't have the technology? So before the Promethean board, I had a projector and just my laptop, and it still worked because kids could use my computer and project it on the wall and still have that full use and see the wonderful components of Brainingcamp.
Wonderful. Emily, did I see you raising your hand as well?
Yes, I was just going to kind of comment what drew me to virtual manipulatives, because I've been using them pre-pandemic. And one of the things that really drew me was I would do a lot of work with upper elementary and particularly middle school students and students with disabilities, and the social stigma of trying to address mathematical concepts that students were struggling with concrete manipulatives was really real for my middle school students that I worked with and their teachers. Like, they didn't necessarily want to use concrete manipulatives that they felt were associated with younger kids. But as soon as I provided them a Chromebook, an iPad that had the virtual manipulatives, they were really hooked and willing to engage in mathematical concepts that they were struggling with, that they felt that there was some kind of stigma attached to using the concrete manipulatives. And so that's what drew me in, as a way to get access to students who were struggling mathematically, but were resistant to using some of the concrete manipulatives.
Great. Yeah, I was as a former middle school teacher, manipulatives changed the way I taught. Bottom line, that's what they did for me. So you mentioned upper elementary, middle school, and then this question is for anyone. How do you, and this came from some of the folks who registered, about shifting the need, or how do you help upper elementary, middle school teachers see the value in manipulatives? How do we get them to use them as well?
I I teach in an elementary school. So I can only speak to the upper elementary grades, but I do a lot of modeling in classrooms. And I feel that some teachers are just afraid or are not comfortable with using manipulatives, but with practice and with seeing it, they gain that comfort. And over time, they do get better and they see, oh, this isn't as scary as I once thought it was. And so it just takes a little bit of time and seeing maybe some of the videos on the website, gating that practice and that fluency with it. But the modeling for me has helped some of those teachers take that leap.
Right. And then with middle school, go
I was
ahead.
just going to jump in and say, I think it's really important to embed it within teacher preparation. So one of the things that I do is make sure that when my math methods class, I have students engage with the virtual manipulatives, my pre-service teachers, so that they are aware of them. And my university has purchased some license for Brainingcamp so that they can try this out and they get comfortable before they go in the classroom. And we explore ways in which they can successfully integrate these with students with disabilities, students without disabilities. So they have that time to play, to get used to it. And they think about ways in which they can use it prior to getting that first time job as a teacher.
Yeah, because they're not going away, right? And they have to, and I think the pandemic accelerated a lot of those technological pieces for education. Let's see. I'm just quickly looking at the chat, see if there's anything. One of the questions we had, Miriam, you talked about Cuisenaire rods and strip diagrams. Would you mind kind of showing how you use those for word problems?
Sure. I'm going to go ahead and share my screen. Let me see if I can find where I need to share. Let me see. Is it this one? Can y'all see my slideshow? Making sure y'all can see it.
Yes.
Okay. I had this. I'm going to go straight to the strip diagrams. There it is. Okay, let me make it as a slideshow. So basically, this right here, you're going to see this goes for addition, subtraction. And so what I do is that's where we figure out, like, that's your whole, and we have that concept of so we have a total. Okay, so if we have a total, then let's look at what this word problem says. And I did this right here as a mini lesson. And I did create this as my own task because the tasks in Brainingcamp, they're absolutely fabulous. But sometimes, there are times where you just want to create a short one or your own. And so that's something I really love about Brainingcamp is that I can create something that I want personalized for my classroom, what I need, and then I can share it out with them. So this is what I did. And then so right here we have where we talk about it together. Okay, what are we looking for? We're looking for total birds, the robins. And so we just fill it out together. And you can see here, I said guided practice. So I do gradual release. And so I have the mini lesson. Then I have a share code for another one I had done, and they shared it and they all did it with me. These are the students. I know you can't see it because it's kind of small, but they do it along with me. And then eventually what I've done before is I'll say, okay, guys, now you're going to do the last one or the last two. And because it's on live, I can see what's going on, who gets it. So I love it because it's immediate feedback. I immediately know who's getting it and who's not getting it because I'm able to see it right then and there. And then I'll know if I need to reteach something. And then right here, I put a big arrow mistake because sometimes we do make mistakes. And technically, this strip diagram was an incorrect representation, okay? Because this was based on division multiplication. And looking at here, I noticed there was a mistake because, in division, one of the things that my students struggle with is, okay, do they have the groups or do they have what's inside the groups? And so to find the strip diagram that matches what the word problem says, because that's what they're tested on often on our state exam is the strip diagram that represents the word problem. It was in here that there's 4 songs. So I was supposed to put 4 groups. And somehow I think I did the opposite. I can't remember. I put 3 and the students caught it. Like, wait a minute, miss, those aren't the groups. And I was like, good for them. And, okay, I made a mistake. It happens. But that's the beauty of Brainingcamp too, is finding those mistakes. That's what I love the most about Brainingcamp and using their live feature, is that, we can look at it and go, oh, look, guys, there's something here. Can we help this person out? It's a safe place in my classroom to make mistakes. We know mistakes are proof that we're learning. I always tell them that mistakes are good. We learn from them. And so when they found my mistake, I was excited. I go, you see, I'm glad you found that mistake, because that means that you're understanding, how the strip diagram should be. So that's how I use strip diagrams.
Oh,
Oh,
awesome.
the Cuisinart Ross for strip diagrams. Sorry.
Yeah, no, I'm with you.
I'll stop.
So were you able to, so one of the features that I really think is neat in Cuisinart rods is the ability to take out the fill and turn the fill off, and then you create the like the tape diagram or strip diagram like you see in the standards or in some of the textbooks. All right. Let's see. Well, there was some questions about how to incorporate virtual manipulatives in whole group or in an intervention setting. But I think, Miriam, you just kind of shared how you did it in a whole group setting, right? Dr. Bauker, Nikki, like in your work as interventionist or researcher, when you're working with small groups, is it something similar?
If it's small group, sometimes I will have the students come up one at a time to the Promethean board. We also are one-to-one districts, so they have their own Chromebook, and so we have the ability to use the live feature. So I will use the live feature in a classroom when I'm modeling, or even small group, and we'll highlight a particular student if they're doing well, or if they're having trouble, we'll pull that up and we'll talk it through that way as well.
Okay, I'm sorry. I was looking at the chat and I saw
Someone did have a question about what is the fill, and I was going to draw your attention to that.
Oh, yeah. If you want to show us.
Well, the fill in terms of, they asked about how to take the color out.
Yeah, then the Cuisinart rods. Here,
I'll let you do it.
Let me go to
faster at it than I am.
Well, I don't know about that, but we'll see, right? So I'm going to try to answer two quick questions in one fell swoop here. All right, so I'm logged in.
I love taking the fill out with the pattern blocks with my first graders. They have a lot of fun with that feature.
Oh, I bet. So I'm going to go to Cuisinart rods, and I'll quickly show you there's different workspaces, because somebody asked in the registration, how do you get the values on the Cuisinart rods? I'm going to choose whole numbers, and now you can see if the white rod is 1, then all the other values follow. So I'm going to make a quick. I'm going to try and talk and type at the same time. Pardon my typing. All right. There we go. I go back here. So here, essentially, looking at ways to make 10, right? So I could go 1 and 9 and so forth. Everybody's with me. But there was a question about how to create or how to turn the fill on and off. All right. So I'm going to take one of these out here. If I click on it, I've got some options. I can copy it. I can delete it. I can rotate it 90 degrees, or I can turn the fill off. We also have, that's what I was referring to, we also have a Cuisinart rod that is adjustable. So it goes beyond just 10. So the other question was how to share this with students. Up here in the upper right-hand side, I can click share. And now this generates a share code. I can either have a link or an 8-character code. I'm going to copy that code. I'm going to put it in the chat. And so now what this creates is a unique copy of that page for my students. So now I've got the share code. Kids can place it in this share code box, click go, and now they have their own version, their own copy of that share code, of that content. I like to think of it as I've gone to the the copier and I've made a copy of a worksheet for each of them, only this worksheet is interactive. So I like to use that that analogy. So hopefully that answers those two questions that had come up in the chat. So we've got about 5 or 6 minutes.
Tina has a question about
Oh,
the
perfect.
share codes. You can keep the share. I keep mine in a spreadsheet and you can reuse them. It doesn't change the master. If I'm answering your question correctly.
Correct. Yes, you are correct. So anytime you make a change to an existing share code, you have to generate a new share code.
Oh, there it is. Oh, that looks similar to mine.
So this is
Mine looks very similar to that one.
So, well, great minds think alike, right? So I'm glad you're monitoring the chat a little bit, Nikki, because share codes are good for as long as you have a Brainingcamp license. They're not unique to your account. You can share them with your colleagues. These are some of the share codes that I've generated over the last couple of years. I've also got ones that have Common Core standards with them. So yes, they are as good for as long as you have a valid Brainingcamp license. All right. Go ahead, Miriam. Did you have a question?
Yeah, there was someone who had asked, how can I give them feedback? How can I see my students' work? What I have typically done is you can do a share code to them, and then I teach them, I train them in how to create their own share code after they've completed the work to send it to me. Now, we use something called Schoology. And so they send it back to me, Schoology. Or if you do, I know a lot of teachers use Google Classroom. They can totally send it back to Google Classroom and you can see their work and then you can comment back on their work.
And I've done that too.
Yeah.
The codes go back and forth through Google Classroom. And I've also given, Carolyn's asking about Go Live. I've done feedback through the Go Live component as well.
Yes, same.
Yeah, maybe time permitting after this, we could do a live session near the end. That would be kind of fun for folks.
Live is my favorite. I absolutely
Mine too.
love live.
Well, now that we're spending all this time about it, talking about it, so why don't we, Dr. Bach, are you ready to share some of the research?
Sure.
Yeah. And then in the meantime, go ahead. And then in the meantime, maybe Nikki or Miriam, if you want to maybe bring up your favorite share code and we can go live.
Excellent. Before I switched over to my PowerPoint and research, I know that Vanessa had indicated about the partial products with the factor and the base 10 block. So I just did a quick one up here while we were talking, just to kind of show a visual so that you can explore. So I'm on the web version, the base 10 blocks, and went to the factors and then put up something for partial products with what I call the factor track. So I just wanted to share that really quick because I know that came up in the chat, and then I will move over to my PowerPoint. So I will bring that up and just share that very briefly. And please know that I will be brief, but try to be diligent in sharing some of the research. So do know I'm not going to talk about all of this, but I just want to make the point that there is a lot of research out there that looks at virtual manipulatives and students with disabilities or students at risk. And it's kind of broken into 3 main areas. One is explicitly comparing virtual and concrete manipulatives to look at the efficacy and efficiency and student outcomes. Another is looking at virtual manipulatives in and of themselves as a tool. Like if we give students virtual manipulatives, do they have greater acquisition? Or are they able to acquire, maintain, and generalize? And then the third is actually utilizing virtual manipulatives as part of an instructional sequence. So some people may be familiar with what's known as the concrete representational abstract instructional sequence, or the CRA, or you might know it as the CSA. I've done a lot of research, and my colleagues have done a lot of research looking at switching out or substituting virtual manipulatives in place of concrete manipulatives and using a virtual representational abstract instructional sequence, and finding that students are this is a very effective, and that students can acquire the mathematical content as well as maintain and generalize with these virtual manipulative based instructional sequences. So just to be really brief, so we have examined Brainingcamp and to look at the ability of the number line to support students in terms of understanding addition and subtraction. And so we looked at high school students with intellectual disabilities and autism spectrum disorder, and saying, can we get these students who previously struggled with addition and subtraction, utilizing the Brainingcamp number lining, knowing how important it is that students have a number line? Can we teach the students to effectively use the number line to solve computational problems? And then are we able to generalize it to a real world application, such as utilizing Brainingcamp's clock manipulative? And we found that students were able to acquire, we had pretty good maintenance data. So we were pretty excited that not only did they acquire the skills of being able to do double digit addition or subtraction with the number line, and having those, right, the arrows, and being able to visually show what number we are starting at, and then the arrows to be able to represent our second add-in, right, was very important. So we had really good accuracy data in terms of the intervention, and then really good maintenance data. So the students were able to maintain. So we stopped providing instruction, and the students were able to maintain their accuracy for 2 to 4 weeks post-intervention, which is really important. We always try to make sure that our students can maintain the mathematical skills that we're targeting, not just acquire. As I mentioned, one of my big areas is looking at virtual manipulative based instructional sequences. And I already noted how much that I love the fraction tiles. So I've done a lot of work with the fraction tiles. And in this particular one, we were looking at, can we take students from using virtual manipulatives to being able to successfully solve the problems with the abstract or numerical only strategies, right? So if we're adding fractions with unlike denominators, their ability to do that mathematically without having manipulatives. I have referenced the CRA, or the concrete representational abstract instructional sequence, and we have done research with the virtual representational abstract. We've also found that there are some situations in which the drawing of the pictures is particularly challenging, and in fractions and algebra happen to be 2 of them. I always make the joke in all my fraction studies involving a representational or drawing phase, Emily gets really good at drawing the fifths and the tenths. I'm not always sure the students get really good at drawing the fifths or the tenths. And so can we take students from just being able to solve these problems with virtual manipulatives to being able to solve them with numerical strategies, or that abstract phase? And for 3 of the 4 students, that was highly successful. They were successful with the virtual manipulatives and were able to make that complete transition to the abstract or numerical only strategies. One student was a little more challenging, and clearly this is not to be unexpected when we're talking about middle school students with intellectual and developmental disabilities. But in general, we found great success with just teaching with the virtual manipulatives and then transitioning to those abstract or numerical only strategies. As I mentioned, again, the VRA being a counterpart or a modification to the evidence-based practice of the CRA. We've used this with elementary students who are at risk, so struggling students, and we've looked at the ability to do the virtual representational abstract instructional sequence with these elementary students who are deemed at risk, or students who are struggling mathematically. And we looked at, in this particular study, 3 different mathematical behaviors, include thinking about multiplication and using the color tiles, and division using the color tiles, and then double digit subtraction with regrouping using the base 10 blocks. And then again, the VRA instructional sequence has students go from being able to solve and demonstrate their ability to solve the mathematical problems with the virtual manipulatives. We don't move on until they've demonstrated mastery or an understanding with the virtual manipulatives. We then transition the students to being able to do so with the drawings, right? So representing with pictures, And then again, when they've demonstrated mastery or understanding to solve with the representation, move on to new numerical or abstract strategies. And so again, in this study, we were able to find success for all of the students in terms of being able to solve the targeted mathematics with the virtual manipulatives, transitioning to the drawings or the representation, and then being able to move on to the abstract. And if we do the virtual representational abstract or the VRA instructional sequence, we found that we have been able to successfully do this with students in as little as 3 to 9 sessions. So potentially sometimes 2 to 3 sessions in the virtual, 2 to 3 sessions with the representation, 2 to 3 sessions with the abstract, and have students to acquire those mathematical skills, and in a large part also be able to maintain. One of my favorite studies or research that I also do is to show the effectiveness or the efficacy of virtual manipulatives as I compare to concrete. And this is really where we began, because before we thought about, can we effectively, use virtual manipulatives as a tool? Can we think about modifying the CRA to include virtual manipulatives to address that stigmatization, or to be able to address the innate interest that students have in using technology? We started in my original research with virtual manipulatives, simply said, are virtual manipulatives just as effective as concrete? And we started this with base 10 blocks. This particular study, I show up the algebra tiles because I said, I love algebra tiles, but we have done this with fractions. We have done this with with base 10 blocks, with addition and subtraction, algebra tiles. We've done this with a whole variety of different virtual manipulatives from Brainingcamp. And over again, the research has shown that students are just as effective with the virtual manipulatives as the concrete manipulatives. And in almost every study, students were more effective with the virtual manipulatives and more independent. So they had greater independence in being able to solve the problems with the virtual manipulatives than the concrete. So that means they required less from me as the interventionist or the teacher as the interventionist to use the virtual manipulatives. And almost to every student, they reported preferring the virtual manipulatives to the concrete manipulatives. And we have done this research with elementary students as young as first grade up through upper middle school students, and obviously with this example, algebra. And so time after time again, we've shown that concrete manipulatives are just as effective. Virtual manipulatives are just as effective as concrete manipulatives. There is a student preference to this, and we actually can demonstrate that students can actually become more independent and less reliant or dependent on the teacher or interventionist with the built-in scaffolds and supports of virtual manipulatives than concrete manipulatives that will require more teacher or interventionist intervention. So, and we are quite excited about our studies that look and show the effectiveness of virtual manipulatives. My last point, and I want to be mindful of the time because I know we have a lot of great things to share, is just a brief summary is overall throughout, and there's a lot of different studies out there. The summary of the research is virtual manipulatives are effective for students with learning disabilities, students at risk, intellectual disability, ASD. We have solid research for a variety of these students. They are effective as a tool on their own, so just using to support students, as well as part of an instructional sequence, such as the VRA or variations of that. As I mentioned repeatedly, students are just as effective and efficient and independent with virtual manipulatives as concrete. Do know that myself and colleagues have done actual validation to be able to call virtual manipulatives an evidence-based practice. So we have applied quality indicators and standards so that we can with confidence say that virtual manipulatives are an evidence-based practice for students with particular disabilities. But I will just put this caveat out. We do need more research with younger students. We have some emerging with our younger early elementary, but that's definitely an area of need.
Wow, that's amazing. That's I didn't realize that the research was that positive as concrete. That's wonderful. That leads me to a question that came in when someone registered. Do you recommend a mixture of hands-on manipulatives and virtual?
I do. I think there's still a place for concrete. I wouldn't say that concrete completely replaces virtual, but I would say that teachers can use virtual manipulatives with confidence, right? I mean, I really do believe that students need to be able to be independent on the Chromebook or the iPad or the computer to be able to successfully use the virtual manipulator. They need to have some of those basic technology skills. And so I still think that there's a place for those concrete manipulatives, but time and time again, when we're looking particularly at older elementary and middle school students, we have shown that virtual manipulatives are just as effective as concrete. So if you don't have concrete, you're in a virtual school, or you really want to avoid some of that stigmatization and engage students, I think that it's safe to say you can use virtual manipulatives with great confidence.
Wonderful. So that virtual manipulatives could be the way to the question about incorporating them more often in middle school. Virtual manipulatives certainly could be those, I'm going to say, sense-making devices that help those middle school students.
And I can say that I definitely still use both. And so she's right, because I am an elementary teacher, I do feel it is important to incorporate both because of that kinesthetic learning that some kids, they need to touch. So I've often incorporated both, and I in the slideshow I had created, I'm going to share, if that's okay. I'll show you real quick.
Yep.
That I did do that, where I had started with, let me see if I can find it. I think it was the perimeter and area one. Here it is, where I started off just so they can get the idea of perimeter and area, where I had it. There's the quiz and their rods that I love. And we just talked about it, how it works. And then we go on into actually using the rulers and putting it together. Another one over here, you'll see we started off to talk about how we can find perimeter and area using when it's just the unit squares versus, wait a minute, but what if I don't have enough unit squares? Because again, we're introducing it in third grade. And so this is the first time they see something like this. It's actually, I believe, the first time they even know what perimeter and area is for third grade. And so I show them that, and then we go into the kinesthetic, the actual, and it was great because I was like, hey, I don't have enough Cheez-Its. Like, what do I do? I don't have enough Cheez-Its, guys. I only got one box. What do I do? And there's so many of y'all, and we can't fill it in. And they're like, oh, wait, I remember when we did it, we only have to do the length and the width. And so that's how they use the hands-on. And because we practice together with Brainingcamp, and then we do the hands-on, they get both. Because I really believe that the hands-on, the kinesthetic learners, they get it. Because if for some reason digitally it's something that they still need more practice, I think that it helps them to connect it. So I think it's important to incorporate both. I do incorporate both.
I love your idea of Cheez-Its. When you posted that on Twitter, I'm like, that is genius.
Thanks. Well, I got to shout out to our curriculum team for Klein ISD. They had that idea, and I'm like, I'm taking it. When you have math with food, they're going to be drawn in.
That's a win-win.
And so they loved it, and they had the Brainingcamp. It was all, and you can see it's there. It was great. And again, there's the mistake that one student, this is a student, and one thing real quick for live that I like too, the students get so excited to see their work on the screen. So they're more motivated to do it. And even if they make a mistake, they're excited. Yo, that's fine. I'm like, oh, okay, that's great. That's great. So something great about it. So I'll stop the share. There you go.
That's wonderful. Yeah, don't put away your concrete manipulatives. Not at all. None.
They work hand in hand.
Yeah, that's right. We don't want to do that. We're Brainingcamp. We don't say put away the concrete stuff, only virtual, right? We know that much, that we want to use both, and they both have power for kids. All right, Miriam, did you want to share and start a live session?
Okay, sure. Let me get into that. I guess I can get into Brainingcamp, and let me try to get out of this thing. Hold on, sorry. So that I can.
Right. I kind of.
There you go.
Just kind of threw you into it.
No, you're fine. Okay, I already have this one in here. So let me get the live code so I can show them how it works for those who don't use a live feature.
Could you share your screen? Oh, there you go.
There it is.
All right.
So this is one that I had created, and I liked it because I've seen it like this where they do offer this, but they don't show the fractions. Of course, you have the option of showing them here. I remember that you can have the option to show them like this, but I wanted to challenge my students not to use it because oftentimes on the test, they won't have the fraction shown. So that's what I've done before. I like that, but I'll go ahead and let me go back to blank, share this code. So for those who don't use live or want to know how to do live, I always go to share. You press live, start live session. Here we go. And there it is. So all of you fabulous people, you just put in that code and you will start seeing when you put it in, you copy that code, you have to open Brainingcamp. The one person's there. There we go. There we go. So there we have all these in there. And then what you can do is you can go ahead and put in, I have my kids use it with their the drawing tool at the bottom, and then I can see what they are doing and I can see if they have any mistakes. I can see oftentimes, now I like this right here. I see the initials that can be edited to just do the initials so we can know who they are, or you can just have the numbers to keep it anonymous. The only thing is you have to know who's what number. And so I have done it where I say, put your initials so I would know who it is. And yeah, so then what I've done is as the students start working on it, so those of you there, you can just start working on it. I oftentimes load it and I show them, let's see if I can do this here. So I'll show them what it looks like, but I know y'all are still working, so I'll let y'all work. And then I've done it where I showed it live so they could see their work and see what's going on. And yeah, and then here's the 4. I like the 4 because it's bigger for others to see. Like this student is doing phenomenal. See there, I like how this student is putting in 1/8 to label it so they could understand unit fractions, that 1/8 plus 1/8 plus 1/8 makes 3. That's a great strategy. So that's just kind of an example of what I would do as I'm teaching, and then I could just close it. So that's how I use the live feature. I don't know if Nikki, you have a code, you want to show how you use it, but this is just a real quick how I use it with my students.
It was exactly the way that you did it. And for those that are saying they're not sure their students can do it, I've been doing it with first graders. The first couple times are not pretty.
Yeah, that's true.
And you
That's true.
just have to get past it. I had modeled it in a first grade classroom and it was rough, and the teacher was wanted it to be smooth and perfect. And I said, we have to move past that. And then we had weather. So we had a DL day, and she had texted me and she's asked, well, can I do Brainingcamp live if they're at home? And I'm kind of was caught off guard. I said, yes, you can do it with them at home. And so the next day she's like, it wasn't perfect, but I did a lesson through live while everyone was at home. And I never would have thought this teacher would have attempted this, but I was blown away. So I do think that for the younger grades, it will be hard. But in the classrooms in my own building, where we've been doing it a lot, and again, in first and second grade, they are now pros at it. So with practice, like anything, they will get better. They know how to put their initials in. So just, I think sometimes we underestimate our students, and they love it. I like to send them the little emojis or little messages.
Oh yeah.
And I don't tell them. And then they say, oh my goodness, I just got a smiley face, or
I'll just do a random one there so I can do it. It's right there. So you can know it's right there.
Yes, they love getting the little messages. And I had mentioned earlier that students love generating their own share codes. So if they create their own problem, they can generate their own share codes, share it with each other. And you really then are creating problem solvers who like to create problems and share with others. And then math really becomes beautiful.
And may I also say something? Oh, may I speak?
Yes. Yeah.
I do want to say something that is very helpful for to have Brainingcamp too. Is I don't know how the other states are, but I know for our state, we are just specifically doing testing online. It's all online testing now. It's not on paper. And so being able to manipulate all of these manipulatives to be able to create a graph, like that's the latest thing I've seen. I'm like, oh yes, that's one of our testing items that they have to build it. And so, one of the concerns teachers have is like, well, how are they going to be able to do these new testing items? They've never done it on computer. I'm like, well, Brainingcamp is really helping us with that transition. So that's why I'm a big advocate in telling my teacher friends and all of those in my campus, like, you want to use it because then it'll be more familiar with them when it comes to online testing, because they have to be able to understand. They have we mentioned having the actual hands-on, and then doing the digital. It helps them to get ready for the digital testing.
Yeah, that's a great point. It gives them a little bit of that exposure to that type of thing, like they're seeing in the online environment. Well, I want to be respectful of everyone's time. I know that there were a few questions that may not have been answered in the chat. There were some questions about live. We went through that quickly. I did put a link in there to our tutorial video on live. I will make sure that those links get sent out with the certificate of attendance. So look for those. But I really, really first of all, I want to thank the three of you for taking time out of your busy schedule